All right, greetings, YouTube. This is Mr. Phifer. As promised, this is the remainder of the notes from today, where we ran out of time, so I didn't want to keep you, so I'll let you go. And this is the remainder of the lecture from this morning. So in class, the reason that I got it wrong at the end, you see it here in purple, I forgot to write natural log. So I looked at it as soon as it got out, I found it. Forgot to write natural log, so then when you do it, I got 1.74%. So let me go ahead and do these last couple of ones as if we were in class. So it says to solve, so I'm going to start by rewriting the original 0.5 to the power of x plus 7 strictly greater than 19. Okay. Now if I wanted to solve for x, I'm going to move things away from the x, so I'm going to start by subtracting 7 on both sides. So then these cancel. So then we get 3 times 0.5 to the power of x is strictly greater than, 12? Then divide both sides by 3. So then you get 0.5 to the power of x is strictly greater than 4. And then to get that out of the exponent, take the log of both sides. So I'm going to do natural log. I'm going to take the natural log of this, and I'm also going to take the natural log of this guy. Okay. When we take the log of the left, that allows the exponent to come out. So I'll continue over here. So then we have x times the natural log of a half, strictly greater than the log of 4. So then to solve for x, what's the log of a half? Well, notice that the log of a half is the x is between 0 and 1, so that y value log should be negative. So when we divide both sides by the log of a half, we're really dividing by a negative. So then if we're dividing by a negative, what's going to happen? So then x should be less than or equal to that expression on the right, the log of 4 over the log of natural log of a half. And then that expression is, let's see it in the calculator. So if I clear, I have the natural log of 4 divided by the natural log of 0.5. And we get negative 2. Okay? So then x is strictly less than negative 2. Solve, and then interval notation, we're basically saying anything from negative infinity up to negative 2 in parentheses is going to work. Okay? So we're just going to test a few values in the original. Okay? So what I'm going to do is going to do my y equals, clear. I'm going to put in my left side, which is a 3 times 0.5 to the power of x and plus 7. Okay? I'm going to quit, clear variables, y variables, y1. So now we're saying anything to the left of negative 2 should work. So if I try like negative 3, it should work. 31 is indeed bigger than 19. If I do negative 2, it should be exact. But it's not. It's going to be false because 19 is not bigger than 19, so that's fine. If I try like negative 100, it should work, right? Okay, and that's 10 to the 30. That's a huge number, way bigger than 19. And then something that should not work, maybe if I try let x be 0. That's to the right of 2. Or equal or to the right of 2 should not work. So 10 is not bigger than 19, okay? So on and so on. So anything strictly to the left of 2 in this case, of negative 2 should work. So that's that one, okay? And then I think is that the last one? That is the last one. Here's the last one. I'm so excited, yay. Okay. So I'm going to start by rewriting the original. Log of 1 minus 3x is strictly greater than 2. To cancel the log, we're going to say e to the power of the left and e to the power of the right. Okay? So then the e and natural log cancel each other. So we have 1 minus 3x is strictly greater than e squared, right? If I'm solving for x, subtract 1 on both sides. So then we get negative 3x is strictly greater than e squared minus 1. Notice this difference of squares if that were to come in handy, but I don't think we need that here. Then we're going to divide both sides by negative 3. And what happens? Again, we're dividing by a negative. So the inequality flips. So then now x is going to be less than, and that's a negative 3. So then e squared minus 1 over negative 3. Then what I'm going to do is here, clear. Ooh. E squared minus 1 divided by a negative 3. Can we get a fraction? No? Okay. So I'll say it's approximately negative 2.130. Okay. So then I want to take that approximation and plug it into the original. Oh, no. That's not. Let's back up. So what we're saying is the solution would be negative infinity up to negative this 2.130. Parentheses and parentheses. Okay, let me check in the original. So now what I'm going to do is write the original. So I go to my y equals and clear. I have the natural log of 1 minus 3x. Okay, and I'm going to quit. And then I just want to recall that y equals business that we had. Yeah. So now, anything to the left of this should work. So something like negative 3 should work in the original. So let's try negative 3. We should get something bigger than 2, and we do. Let's do negative 4. And we do. Let's try something like negative 20. Just to make sure it continues to trend. Okay, that's bigger than 2. Now, let's try something less to the right of this number. Something like 2. 2 should not work in the original. It should not be bigger than 2. And it's not. So on and so on. The further you go to the right, it's not going to work. Okay? So I think that actually was the last one for today. So I'll post these notes on... So I will post a copy of these notes on Box like we normally do. And again, so this weekend, get ready, do your best, study hard so that later you can play hard. All right, gentlemen. Have a good weekend. Be sure to like, share, and subscribe.